Again, so example 8 from chapter 9.4. Let's read through it and pick out the key information. A particle is moving in a straight horizontal line, constant deceleration of 4 meters per second. At time t equals 0, the particle passes through the origin with a speed of 13 meters per second, travelling towards a point A, where OA equals 20 meters. Okay, let's just draw that because it's a little bit more complex than the last one. So we've got O and we've got A. We're told this distance from O to A is 20 meters. The acceleration, so if that's our positive, that's our positive direction. The acceleration is back towards O. So we could put our acceleration on in the positive direction, because that's the direction of increasing x, as minus 4 meters per second squared. Just notice the different arrows that we're using. So this double-headed arrow is an acceleration. This is just defining our positive, and our acceleration should always really go on in the direction of increasing x, which is our positive direction, and then put a minus sign on, and this here is a distance with the arrowheads at both ends. Okay, so what else do we know? Particle passes through a point O with speed 13, so we've got a velocity of 13 meters per second there, and we don't know anything else. And we're asked to find, and that would be t equals 0, and part A then, the time at which the particle passes through A. So we're asked for t at this point. Okay, we're told it's constant acceleration, even though it's negative. So constant acceleration. What are we trying to find? T, so we could call that capital T. We know that A is equal to negative 4. We know U is equal to 13. And we know S equals 20. So there is no V, therefore pick S equals UT plus a half AT squared. Substitute in the values. 20 equals 13t minus a half. Oh, let's put the plus in. A is minus 4, and then t squared. That's a half, just let's make that clear. So we've got 20 equals 13t minus 2t squared. What kind of equation is it? Well, hopefully we pick this out as a quadratic. So how do we like it to be written? Write as positive and equal to 0. So we get 2t squared minus 13t plus 20 equals 0. Okay, now we could use the equation, we could try to factorise it, or you can just tap it in the calculator at this stage. If it's factorisable, if it will factorise, you should factorise it in an exam context, because there may well be marks for showing that working. So we're just going to quickly see if it will factorise using our grid. 2t squared plus 20, so it's got to multiply to give 2 times 20, which is 40, and add to give minus 13. Okay, well 2 and 20 won't work, obviously. We could break the 20 down into 4 times 5. We found something there. 8 and 5 will make negative 13. If we make negative 8, negative 5, and they still multiply to give negative 40, so we're happy with that. So minus 8t minus 5t, 2t comes out as a factor, minus 4 minus 5. So we get t minus 4 and 2t minus 5 equals 0. So t equals 4 and t equals 5 over 2. Therefore, at, where did it ask for? Point A, twice, once when t equals 5 over 2, and then again when t equals 4. So the particle moves in this kind of way. It's going away, it goes past A and it comes back. And it's here on the way out at t equal 5 over 2 and on the way back at t equal 4. Okay, the value of t when the particle returns to 0. So, this time, we want t when s equals 0. So let's list out the information again. Part B, it was still constant acceleration. A is still negative 4. U is still 13. S is now 0. And what do we ask for? The value of t. So t equals, we might just call it t1. Same equation, s equals ut plus a half at squared, the one without v in it. So naught equals 13 lots of t1 plus a half negative 4 t1 squared. Okay, again, we've got a quadratic, 13t1 minus 2t1 squared. Well, that's equal to 0. Probably don't need to make this a positive quadratic, but if you do, then that's absolutely fine. But we can take the t1 out as a factor, leaving 13 minus 2t1. Therefore, t1 equals 0. Well, that's reassuring because that's where it was at the start. So at t1 equals 0, it was at the origin. Or 13 minus 2t1 equals 0. So t1 equals 13 over 2 seconds. And that's when it comes back to the beginning. So if we look back at the diagram, t would have been equal to 0 there. And t is equal to 13 over 2 when it gets back to the 0 there. Hope that's clear. And we're going to do example 9 next.